Chapter 1. Node.js is one of the most popular server-side frameworks. Increasing companies are building their applications with Node.js, for example. Walmart, LinkedIn, PayPal, YouTube, Yahoo, Amazon.com. In this book, we will learn about Node.js together with Express and MongoDB and build a blog app from scratch with them. In the process, you will progress from a beginner to where you can build apps effectively using these technologies. You will learn a range of topics like user authentication, data validation, asynchronous JavaScript, password hashing, Express, MongoDB, templating engines, maintaining user sessions, and more. The app we will build a blog app which lets users write blog entries once they sign up with an account. After the user registers, she can go to the home page and log in with her credentials. The navigation bar will dynamically show different items depending on the user being logged in or out. We'll achieve this using the EJS templating engine. Once logged in, the navigation bar will have a logout item. There will also be a new post item where the user can create a new blog post and upload an associated image file. When she goes back to the home page, her blog entries will be posted there with the username and date posted. Throughout this app, we will learn a lot of concepts and solidify our Node.js, Express, and MongoDB knowledge. What is Node.js? Before you understand what Node.js is, we need to understand how the internet works. When a user opens up her browser and makes a request to a site, she is known as a client. The client makes a request of a certain website to a server, which upon receiving the request, responds with the content of the requested site to the client, who then displays it in her browser. For example, I make a request to Amazon.com and Amazon servers respond back with HTML for Amazon.com. There have been server-side programming languages like PHP, Ruby, Python, ASP, Java, and others which help us respond to browser requests appropriately on the server. Traditionally, JavaScript used to run only on the browser to provide website interactivity, for example, drop-down menus. But then in 2009, Node.js took V8, Google Chrome's powerful JavaScript engine, out of the browser and enabled it to run on the servers. Thus, in addition to existing server-side languages, developers could now choose JavaScript to develop server-side applications. What benefits does choosing Node.js as a server-side language bring about? Firstly, the V8 JavaScript engine used in Google Chrome is fast and can execute thousands of instructions a second. Secondly, Node.js encourages an asynchronous coding style, making for faster code to manage concurrently while avoiding multi-threaded problems. Thirdly, because of its popularity, JavaScript offers Node.js access to many useful libraries. And of course, Node.js provides us the ability to share code between browser and server, since they both use JavaScript code. Based on this, developers have created the main stack, an all JavaScript web application stack consisting of MongoDB, Express, Angular, and Node.js. Using JavaScript everywhere is a major benefit of Node.js. In fact, there is also a MERN stack where instead of using Angular, React is used as the front end. In this book, we'll cover MongoDB, Express, and Node. So installing Node.js. Node and npm have already been installed. Creating our first server. We'll create our first server to better understand how a request and response between a client and a server works. In a code editor of your choice, choose a directory location and in it create a file called index and fill in the below code to create our first server. The require function in Node.js helps us to grab the package in Node.js called HTTP. Require is similar to import or include in other languages. Require takes the name of the package as a string argument and returns the package. We require the HTTP package and assign it to a variable called HTTP. You can then use HTTP as you would any object. HTTP is one of the built-in packages that Node.js provides to perform actions on the server. Other essential built-in packages that we will cover later is the file system access package and the utility function package. Next, we create and start a server with the create server method from HTTP package. Create server takes in a function as a parameter. The function provided to create server is called a callback function. It will be called when the create server function is completed. When it is called, it will be provided the request and response object in the function. We can do whatever we want with the two objects in the body of the function. In our case, we simply log the request URL and after that respond with the text hello node.js in the function body. Server listen. Finally, with server listen, we start our server to start taking requests. That is, the server listens on port 3000 for requests. You can specify any port you want. It doesn't have to be 3000. If you're asking what a port is a specific gateway on the server to host a particular app. For example, if there are multiple apps running on the same server, we specify different port numbers for different apps. Running index.js. In our case, for any request made to port 3000, we respond with hello node.js. To execute the file and start running the server, in terminal cd to the directory the file is located in and run node index.js. So here, hello node.js. More on request and response. Our app currently responds responds only with hello node.js, regardless of the URL entered after localhost 3000. To have different responses based on different URLs, add the following code in bold. Using an else if statement in the callback function, we check for the request URL, and depending on its path, we respond with different messages. If the URL contains about, we serve the about page. If it contains contact, we serve the contact page. And if it's just /, we serve the home page. If the path does not exist in the if else, we default to the last else clause and respond with page not found and also write headphone 4. Writes the status code of the request. Normally, a status code of 200 indicates that the server responded with a successful response. You can see the status code of your request whenever you request a site from Chrome browser by going to developer tools. Okay. So for the fourth letter, it was a success, hence the status 200. And then if I were to enter page next, it will give 404 and page not found. Responding with HTML. We've been responding to requests with static text. In a real setting, we want to respond with HTML. We'll illustrate how to do this in this section. Back in the index.js, add the below code in bold. We import a file system module fs which helps us interact with files on our server. The readFileSync method from fs reads the content of each file and returns it. We store the content in a variable for each page. Instead of resEnd containing a static text, resEnd now contains an HTML page variable. Okay, let's restart the server. Now that we have been writing a single JavaScript function in our entire application, the single function listens to our web browser requests either from a computer, mobile phone, or any other client consuming our API. We call this function a request handler. Every Node.js application is just like this, a single request handler function responding to requests. For smaller sites, this might seem easy, but things quickly get huge and unmanageable quickly, as you can imagine. For example, a site like Amazon.com, which includes rendering dynamic reusable HTML templates, rendering, uploading of images, and etc. In this book, we build a blog app with Node.js, Express, and MongoDB. Node.js allows us to use JavaScript as a server-side programming language, which gives us advantages like fast execution and being able to share code between the server and client. We understood how a request and response cycle between a client and server works by coding and starting up a simple server example. We handled requests and responded appropriately with both text and HTML.